Hello, everyone. We're continuing with the program and with our artificial intelligence and machine learning in HealthTech. The first lecture will be from Antonio de Castro, and the title of the presentation is Accelerating Innovation in Healthcare with Advanced Analytics. So for the past 18 months, they have showcased an acceleration in vaccine development for COVID-19. But the acceleration in innovation is not exclusive to vaccine and drug development, but it also extends to the whole healthcare and life science community. Innovation applications of AI, machine learning, computer vision, natural language processing are moving from moonshots to the mainstream. This presentation will not only describe the potential value of this application, but also illustrate how they're directly impacting patient care through surgical safety, remote monitoring, and other programs that are recently developed in the context of global hackathon hosted by SAS. So, Antonio, the floor is yours. Thank you.
Okay. Hello, everyone. Thank you for your time today. I hope everyone had a good lunch. I'm calling you from Singapore, and today I'll be talking about accelerated innovation in healthcare. So let me share my screen, full screen. There you go. First, a little bit of introduction for myself. So my name is Antonio de Castro. I'm SAS's senior industry consultant for health and life science. I cover Europe, EMEA, and AP, Asia Pacific. So my background is in economics and statistics from the University of Geneva, and I have 10 years experience in healthcare and life science, so in Switzerland and in Singapore. So notably that, of course, entails clinical research, healthcare operational analytics, also experience in digital health and consumer health. So just a quick sort of overview of SAS in the healthcare industry. We are, I guess, mostly known for life science, notably in pharma industry, but we do have a good foothold in also in the healthcare industry. So these are just some numbers to show SAS's presence. And of course, we are collaborating with leading industry groups in the healthcare industry. So today, really, we want to showcase what we've observed firsthand in terms of the hackathon that we ran earlier this year, and also connect this with the trends and the predictions that were made earlier in the year or late last year by the different sources possible that drives the healthcare industry. So notably, I'm going to speak to you about chatbot for cancer that was developed through using our analytics platform. It's not only for the patients, but also for their friends and family. So as you can guess, there's some NLP used there. Also using computer vision for surgery assistance and training of medical staff. The winner of the hackathon, at least for the HealthTrack, is actually around patient motion analyses to predict disease progression. And of course, there's also a use case or a project that was around creation of synthetic data for clinical research. We have an ebook that explores all the use cases. Of course, I cannot sort of present everything today in detail, but you'll find more details there. And I want to highlight that most of the material, if not all, are actually publicly available. Everything that happened through the hackathon is open for the public. So I'll show some references later on. So as most of you might know, there's really a lot of sources when it comes to healthcare trends, right? There's at a macro level, all these different entities produce every year, showcasing what healthcare trends would be, as well as their proper predictions. There's a lot of intersection there for sure. Different companies or organizations focus on different areas, but mostly there's a lot of intersection. Today, I'll use as an example more on the technology aspect, notably the IDC Futurescape report, and we'll jump right into it. So with regards to healthcare trends and predictions, this is the one coming from IDC for 2021. And I chose purposely, let's say, the more on the latter end of the predictions, and connect them later on with what we've observed with the hackathon. So I just chose three predictions here, notably the digital front door. As we all know, with the pandemic hitting, this is really a key priority. This was accelerated globally because basically no one wants to go to the hospital, right? Or no one unnecessarily wants to go to the hospital now. So the digital front door is really important to first have a filter whether you really need to go to the hospital, or maybe even provide already medical care virtually, or even sometimes even just information, clinical medical information that can help you out. The next prediction, eighth on the map there, is around data platforms. So this is sort of like a general remark, and again, accelerated by the pandemic, that basically the healthcare providers realize that they need data platforms, right? Because with COVID-19 happening, uh, each hospital, each healthcare provider needs an internal assessment of what's going on within their hospitals, whether it's for medical resource optimization, but also to looking into the treatment patterns and who's getting well, who's not getting well. Like, and for that, it's not just the medical data, it's really a lot of information altogether. That's why it's important to have a data platform. Um, During this past year, most of you probably heard about social determinants of health. Well, this is part of that. Like, it's not. It's more than just the healthcare data, but it's really merging it with social determinants of health, for example, to have a better assessment or better anticipation of outcomes in health. The last prediction here is around medical imaging transformation. So it's more or less self-explanatory, but really using computer vision to assist in clinical operations, notably surgeries. So we'll show an example of that later on as well. Okay, so just a quick word on the hackathon and how it went down. Not going to spend too much time on this because, again, this is a data science conference. I'm pretty sure everyone's quite familiar with setup of a hackathon. I just want to highlight that the main activity basically was that for one whole month, SAS gave access to 100 different teams, so 100 different participating teams. We gave them 1 month access to our SAS via platform, right? Which is the latest iteration of SAS's analytics platform, which has a lot of capabilities, which I'll show in the next slide. And then it's, of course, with that 1 month, they would work with the system, develop their projects, and then, of course, the last deliverables will also, I'll show in some of the slides later on, are videos that will be showcasing their projects, explaining how they use the platform, what methods they used, etc. So, and of course, there's a judging process. There will be winners, and for us, it's also next steps in terms of how many of these projects are actually can be valorized either by our partners, by SAS ourselves, and basically take it to the next level. And again, another highlight of this is everything happened within a span of 6 months, even less than 6 months. So a lot of learnings there. People were happy that actually a lot could be achieved in this short time span. And we really encourage this moving forward into the future. So here's a snapshot of the platform that we made available for the different participants. So it's really around, again, it has, of course, a lot of capabilities, but I want to, today I'm going to showcase most of the cases that used the purple parts there, right? Notably around AI, artificial intelligence. So statistics, machine learning, and deep learning, some forecasting optimization, as well as natural language processing, and computer vision. And again, the different teams use the different capabilities in different ways, as we will see in some of the examples later on. Here, I don't want to spend too much time. It's just showcasing a little bit of a snapshot of the different participants. I guess what we want to highlight here is that it really a lot of participants were actually new to SAS, and most, if not all, actually were integrating as well open source together with SAS. So I think there's a little bit of stigma about SAS being, that you need to code in SAS. in order to use SAS, but that's not really the case. We are heavily improving our integrations with R and Python because we know that, well, to be part of the statistical community, this is very important, right? And again, another highlight here is really that 30% of the entries were for the HealthTrack. So the 100 teams, there were really for all the different industries. But I guess it's not surprising that the majority is going to be concerned with health because we're in the middle of the pandemic right now. Okay, and here I just want to emphasize again that all the materials I'm showing here today are publicly available. We're going to go through a couple of them, so we're not necessarily going to dive deep into the material for each one. But again, rest assured that all of these videos that I'm showing here today and the material I'll show here today are publicly available if of interest. So if you're curious about what use cases came out of the hackathon using an analytics platform, they're available with the Hack in SAS. Okay, so now back to the use cases. So again, just linking to the predictions that I mentioned earlier, I want to talk about how the hackathon is really representative of the trends that were observed, that was presented earlier, right? So for the digital front door, of course, this is not a one-to-one comparison, but basically they're linked in terms of what their main function is and their usage. So for the digital front door, the chatbot that answers questions for cancer patients, for their friends and family, is a way, a sort of a digital front door, again, because you don't necessarily need to go see the doctor anymore if you have a chatbot that gives you the information you would need, right? And again, it doesn't mean it's replacing a doctor or anything like that, but there's that first digital front door that can assess whether you need to go to the doctor or not, and also give you information that you need at that specific moment. When it comes to the data platform, we did observe another group that created a data platform to accelerate cancer breakthroughs with using AI and synthetic data. And for the medical imaging part, we have a computer vision use case that increases surgical precision and that ensures patient safety. So I'll show these three later on, plus also the winner of the hackathon. Okay, so a quick introduction here, because I think I'm okay with time. I'll play the video. But Butterfly Data, they're the ones who created the chatbot for cancer patients and loved ones. So they really created this dedicated chatbot for cancer lifestyle advice aimed at the family, friends, and patients seeking information. So there's also that mental health aspect around it, because as many of you know who have encounters with it personally, cancer is not just about the patient, right? It involves everyone around them. So that was really the thinking behind this project, that we need everybody needs reassurance, everybody needs information, and the right information at that. So it's been created not only to provide statistical data, as you can see here on the screen. It's looking into sources. It's capable of making calculations and giving out data depending on the question that's being asked. It also can provide nutritional information and direction to local healthcare services if needed. But also, it's important to create trustworthy links to websites for further guidance. So also, just to showcase that, again, these materials are publicly available, I'll click on that link now to show you where the different videos are. So, oops, it's showing in my other screen. Here is Butterfly Data's video. So again, for each of the projects, there's there's like a short video and a longer video that explains a little bit more in detail and more technical terms what they did. So again, in interest of time, I'll just play this short video that introduces the project.
Hi, I'm Sarah Boltman from Butterfly Data, and our team chose to use the hack in SAS to look at cancer data in Canada. We were very lucky to be joined by a PhD student, Cheng, who is an expert in biostatistics in cancer. So we took a data set that covers the whole of Canada and cancer survival rates for different types of cancer over many years. We realised when we got the enablement material from SAS that SAS Bio 4 also includes conversational AI in the form of a chatbot, and we wondered whether it would be interesting to build a chatbot to enable users to interact with the data in the dashboard. Over the last 12 months, healthcare institutions have been stretched to breaking point by the COVID pandemic, and it's estimated that there'll be many thousands more cancer deaths than there would have been if the hospitals hadn't been full of COVID patients and the helplines hadn't been ringing with people asking questions about COVID rather than about cancer.
Cancer care has suffered terribly through COVID. Actually, as a side, I know people working in the industry who will tell you that they are now seeing patients that should have been screened a year ago that weren't, and many now have inoperable or non-treatable cancers because of it.
We want to be able to relieve the burden on some of those helplines by providing a chatbot that would answer some simple questions and direct people to useful resources, not just cancer patients themselves, but their friends and families that might be asking the same kind of questions that I was asking when my father was diagnosed. What can I do? How long is he likely to survive? What kind of food should I be cooking him if he's having side effects from chemotherapy that might not upset his stomach quite so much? We'd be interested in partnering with any healthcare organisations that would like to reduce the load on their helpline by using some kind of chatbot. We'd be happy to take what we've built so far and tailor it to your specific use case. We're not trying to pretend that this is a substitute for a doctor or for a caring human, but for cases where a patient or a patient's friends and relatives want to ask a simple question and be directed to some reliable resources rather than just Googling and finding any old thing on the internet, we think our chatbot could be the right answer, and we'd be happy to talk with you further about it.
It will be able to track sensitive questions such as, will I be dead soon? This is a very sensitive question and a chatbot shouldn't be answering it.
And I like the fact that this bot thing, we talked about this last time, I think, this idea that you're going to say, I'm a bot, like there's a limit to what I can do here. And answering existential questions about life and death is not the role of a bot.
Okay, so that was, again, one of the videos that is specific to this particular project. And again, I just wanted to highlight that it's publicly available. So let me enter full screen again here. Okay. So that was for the first one with the chatbot. In interest of time, I'm not going to play the video regarding Amesto's project, but this is around the synthetic data for research, and this is the summary of it is in the image that is being shown here. Right, it's really about creating two neural networks. That is, one is to generate the data from electronic health records. So as you can see in the graph there, really based on the electronic medical records, I'm trying to simulate and generate a similar amount of data. And as you can imagine, there are multiple distributions, multiple sort of correlations to take into account when doing this. So with the data generated, what they would do is have another pit it out against the real data, and also have another neural network that machine there, as you can see, which is called a discriminator, that will look at the data whether if it looks fake or not, if it's too far off with regards to the distributions and correlations that are observed with the actual data, and it will flag that, and it will continuously sort of enter a loop to generate more data, or generate that part of the data that doesn't fit or is not representative of a reality. So really, the goal is to create a clinically relevant database to be used for medical research, right? Specifically for diseases that are quite rare, because it'll be too costly and too slow, let's say, to run clinical trials, right? Of course, the clinical trials will happen and need to happen anyway, but for fast research purposes, synthetic data could really be a key and useful asset. So a lot of things happening in that space as well when it comes to healthcare and life science. So as I mentioned, of course, they also have a video. I'm not going to play that in interest of time today. I'll move on to the next use case, which is with its people and Amsterdam UMC. And what they did is a computer vision project that's aiming to help with gallbladder removal surgery, right? So gallbladder removal is a surgical procedure that's done quite frequently by surgeons all over the world. So during the procedure, the surgeons need to gain a clear view of the different structures involved in removing a gallbladder, as you can see in the images there. So one's an illustration and one's the actual video or an actual screenshot. So this view, once you have that view where you're clear to cut, is called the critical view of safety. And the quality of the view is scored by using Strasbourg criteria. So these criteria are widely used in clinical practice. So surgeons in training are coached and rated by qualified surgeons or expert surgeons, which look at videos in which the surgery is performed. So one part of the rating is done by looking at the quality of the CVS. Rating a complete procedure based on a video is, of course, as you can imagine, very time consuming and expensive, right? Because you need the time of the doctors to assess the trainees. So this team's objective, right, this particular project is really to aid in that assessment of videos to determine the quality of the CVS, the critical view of safety. One very important step in the process is to determine the time when the CVS is best accessible, for example. Right. So again, their first goal is really to develop a computer vision model to automatically find the correct time in a video to assess the critical view of safety. So there's some numbers presented here. They were very happy with, let's say, this first attempt or first project reaching an accuracy of 70%. What they did was really look over 600 different videos of gallbladder removal collected and scored by 50 surgeons, resulting in a powerful analytics developed. So the proof of concept, this project, they of course want to fine tune and develop further. And the aim is really to help with facilitate surgical training. So for trainee surgeons, and in the future, really have a perioperative in-stream video analysis. So while the doctors are making the surgery, the operation, that there's a video assistance live happening there. Again, I've shared the links here, but I think in interest of time, I'll skip this particular video. It's quite lengthy, but please, if this is of interest, check it out in the references that I've showed before. I skipped those videos because, again, I want to concentrate on the winner, actually, of the HealthTrack. Oops, sorry about that. Which is analyzing patient motion to predict disease progression or quantify injury and recovery by Pinnacle Solutions. Okay, so this is a much more mature project that they had because it really included a lot of different moving elements, right? So there's a webcam involved. There's a what we call a biosole involved. So it's an insole that detects the movement or the posture of the person. And of course, it requires the people and machine learning that would look into the different movements and patterns. So for this one, I'll play the short video that they have. And the project is called Red Hot Chili Steppers. So this will be the final video that I'll show. Oops. What's happening? It's not loading. Sorry. Okay. Still online. Sorry about that. Let me just click on that again. Yep. So it opened in another window, and here is the short video.
A loss of balance often occurs due to a problem with the signals the ear sends to the brain. These signals usually control our sense of balance and spatial awareness. However, if a person has a condition that affects the brain or inner ear, they may experience a loss of balance, spinning sensations, unsteadiness, or dizziness. Loss of balance can occur for a range of reasons, like an injury to the brain or spinal cord infections, medications, and neurological disorders. Our solution? Use IoT devices and SaaS machine learning to determine a risk score for falling. This can assist with early detection of disease and progression of injury and health. Using a simple web camera, a smart wearable IoT device, OpenPose, and SaaS visual data mining and machine learning software, we have created an objective assessment of a patient risk score for losing balance and falling. The application of IoT devices and artificial intelligence in healthcare present numerous opportunities and use cases. These include training, research, end-of-life care, treatment, keeping well, early detection, diagnosis, and decision-making. The concept of determining a quantifiable pain scale is within our reach. Imagine if we built small IoT sensors into Band-Aids that can track our body movements. We could record, analyze, and provide scores that determine if a person is feeling more or less pain. This could be incredibly useful in determining the effectiveness of prescribed drugs, or even in tracking the negative side effects and risks associated with that medication. Telehealth options can be expanded by using the camera on a patient's own computer. Simple, inexpensive, and disposable sensor devices that have gyroscopes, accelerometers, and pressure sensors can further provide doctors information on in-depth gait analysis and body motion. Finally, the applications of the examples we've demonstrated here can apply to a myriad of other industries: manufacturing, retail, hospitality, and many more. The opportunity is limitless with a simple webcam, IoT devices, and SaaS machine learning software.
Okay, so that was the last video I'm going to play today. I think we're just about time to wrap up. As you can see, Pinnacle Solutions project really is quite ambitious. What they see is that this technology can be used basically as an ID of a person. That's basically the way you walk, your posture, all those combinations is unique to a person, and it has all these multiple potential applications in the future. Just to wrap up, again, I just want to quickly talk about the learnings from the hackathon. I alluded to them earlier already, but really this is the concept of fast prototyping, right? A lot of the participants were really surprised positively about like what can be achieved within a short frame of time. So the idea is really to learn fast rather than what people always say is fail fast. We also, data availability was a big concern coming in from most of the participants. But what people realize also is that there's a lot of data available out there, right? Either it's publicly available data. Notably, there were a lot of projects, of course, around COVID-19. But there's also synthetic data that would be available and for potential use. Also, a lot of companies realize they are sitting on unused data in-house that they can tap into for such projects. Of course, with a proper privacy restriction and security things in place. So, and the last part I want to talk about is really about open innovation. So these are actually two things, right? The first part is that it was an open forum for everybody. So as I mentioned, it's a lot of all of the projects were publicly available, and there were forums where people could talk, ask questions openly to each other, between teams. So it really helped and inspired everyone to have that community, that open community. But also the other sense is having an open platform, right? So as I mentioned, SAS Via welcomed programming in R and SAS in Python, so that we didn't want that to hinder innovation
Sorry,
that's
Antonio,
being delivered. Yes,
if you
this is
can
my
keep it
last slide.
brief, okay. Thank you.
This is my last slide. So yeah, so that's just the last part. I was talking about open innovation. And what I want to say last is really watch out for future iterations of Hack and SAS. We will be rolling them out soon. And as well as, please, if any of these are of interest to you and you're interested in what we're doing in healthcare, please visit our website. Thank you so much for your time.
Thank you, Antonio, for the great presentation. Unfortunately, we don't have time for questions, but if anyone has any question, I guess they
Please
could
reach
just
out
send
to
you a
me.
message. Yeah.
Of course.
Okay.
Of course. Thank you so
Thank
much.
you. Thank you very much. We'll continue with the program, and the next topic is machine learning for COVID detection. The COVID disease had infected hundreds of millions of people and caused over 4 million deaths globally. The disease has raised a serious concern about public health amongst government across the globe, and identification and isolation of people infected with COVID disease helps containing the spread. So the next lecture by Pratik will be a case study of how to use machine learning for COVID detection.